Our question has got three characters: Sipho, Bingo, and Sihle. Sipho is traveling towards Sihle, and Bingo is running back and forth between Sipho and Sihle. Bingo is a dog, by the way. So we have let us draw a diagram to illustrate our situation. I'm going to draw a straight line. So this is a straight line joining Sipho and Sihle, and so this is our Sihle. She's here. There is Sihle. She's wearing a skirt. There she is, and she's traveling towards Sipho at 35 kilometers per hour. She's quite a very fast girl. 35 kilometers per hour. That's her speed towards Sihle, who is here. It's towards Sipho, by the way. So Sipho is here. There is Sipho. He's also traveling towards Sihle, but he's quite a slow boy because he's going at 30 kilometers per hour for whatever reason. Maybe he's tired, we don't know. And he's moving this direction towards the girl, and the girl is moving towards him. So our Sihle is here. So this is Sihle, and this is our Sipho. Okay, and between them, between these two, there is a distance of 100 meters. We are told this in our question that they're standing 100 meters apart, but in between them, there is a dog that is running. Our dog is called Bingo. So Bingo is here. Let me draw Bingo. So Bingo comes here. Here's a head, obviously, and some ears, some big dog ears. There's Bingo and his legs. Yeah, he's running. He's running quite fast. So let's show that, diagram. And he's going to tell. Okay. Anyway, we have Bingo there, and this Bingo speed is 60 kilometers per hour. It's quite a fast dog. So Bingo is running back and forth. We know dogs love doing this. They love running back and forth for whatever reason. They're just excited. We don't know. But so we are required to calculate the distance that the dog is going to cover before these two meet. Obviously, they're going to meet at some position here. Judging by their speeds, obviously, if we say this is the middle, where 50 meters apart, because the girl is quite fast, obviously they're going to meet somewhere this side here. That's where they're going to meet, to closer to Sipho, by the way, because Sihle is quite fast. We know that, but it's not relevant in this case. We want to know what is the distance, the total distance that this dog is going to cover before these two meet. This is the question. It's quite a simple question, but then there are several things here that can make it confusing to students or to novices. So I'm going to explain how you tackle such a question or the reasoning behind this. That's what I'm going to explain. So I'm going to wrap the diagram. Obviously, drawing a diagram when you're doing mathematics is quite very helpful for you to understand the situation that you have. Now it makes more sense after seeing Sipho and Sihle and the dog in between running back and forth. Now let's do the calculation now. Forget the diagram. And now the calculation. So let's say the solution to this question. Okay. Let's reason out. We have to find common things here. There are things that are common to this. The common to all our three characters, Sipho, Sihle, and the dog Bingo. There's things that are common. One, all are in motion, all are moving, or all are in motion. Sipho is moving, Bingo is moving, and Sihle is moving. That is common. And they're going to be in motion for the same amount of time. See? For the same amount of time. For the same amount of time. Let's just say for the same time. Okay, for the same amount of time, whatever it is. It's fine. So for the same amount of time, let's call that time that the three are going to be in motion. Let's call it t, small letter t. So Sipho is going to be moving for t seconds or t hours, whatever it is. Sihle is also going to be moving for t hours. and Bingo is also going to be moving for t hours or t seconds. For this time t is common to all of them. So once Sipho stops, Bingo stops, and Sihle stops. It's common sense, right? We know this. So this is going to be the basis for our reasoning. So we have to find this t. Why should we find t? We know that distance is equals to speed times time. So for Bingo, we already know the speed. We know the speed for Bingo. So we just want to know the time that Bingo has been doing this back and forth running. Once we know it, we multiply by the speed, then we know the distance that Bingo actually traveled. So the first task is actually to find the time, this common time t. We are going to be aided by the information for Sipho and Sihle. Let's go to that now. We know that if we multiply v, the speed for Sihle, we multiply it by t, and we add that to v for Sipho, multiply this by t, this should be equals to 100. In other words, what I have here is the distance. This is the distance for Sipho. So this is distance traveled by Sipho in time t, and this here is the distance traveled by Sihle in that time. So this is the distance traveled by Sihle. If we know this distance for Sihle and Sipho, if we add them, we should get 100 meters because the distance between them is 100 meters. All right. But we know Sipho's speed, and we also know Sihle's speed. We know that, but it is in kilometers per hour. This 100 here is in meters. So this is in meters. We have to convert Sihle's speed into meters per second, and also Sipho's speed into meters per second. We do that by dividing by 3.6. So let me do that calculation. So v for Sihle, is equals to her speed in kilometers per hour, which is 35. We divide that by 3.6. We'll get her distance, her speed in meters per second. So 35 divided by 3.6. The answer is 9.722 to 3 decimal places, by the way. 9.722 meters per second. This is the speed at which Sihle is traveling. And then we do the same for Sipho. V for Sipho will be equals to 30. You divide the 30 by 3.6. We get 8.333 meters per second. Once we have this, we substitute into our equation. We substitute this here and this here. Then we can solve for t. Once we have our t, we are almost there. So let's wrap here and rewrite the equation. In fact, I'm just going to do the substitution, and we calculate our t. So v Sihle is 9.722 times t plus the v for Sipho, which is 8.33 times t. All this should be equals to 100. So from here it means therefore t is equals to 100 divided by 9.722 plus 8.333. I'm just putting this all at once so that we calculate our time. The time will be in seconds because 8.33 and 9.722 are actually in meters per second. So we're dividing our 100 by 9.722 plus 8.33. We get 5.539. So this is 5.539 seconds. This is our t. It means Sipho was moving or was walking for 5.539 seconds. The same applies to Sihle, the same applies to Bingo. So we now also know the time that Bingo was doing the back and forth running. We now know it. We are going to use that to calculate the distance covered by Bingo. So let's go to Bingo now. Bingo the dog. Bingo was traveling at, so let's say V Bingo, the speed for Bingo. We are given it as 60 kilometers per hour. But remember, we want everything to be in meters. So we want to convert this to meters per second. So let's divide that by 3.6. We divide 60 by 3.6, we get 16.667 meters per second. This is Bingo's speed. With this now, we can calculate the distance covered by Bingo, which is what the question was asking for. Distance for Bingo, by the way. Okay. Will be Bingo's speed, which is 16.667 times our time, which is 5.539 seconds. We do this, we get our distance in meters. So we got 16.667 times 5.539. This is 92.319 meters per second. That is the distance covered by Bingo. That is what the question was asking for, and not in meters per second, I'm sorry. The distance is just in meters, 92.319 meters. But this is the distance covered by Bingo as he was running back and forth between Sihle and Sipho. That's it. It was quite a straightforward question. Thank you for watching the video. Subscribe to the channel.